The National Electrical Code, NEC, does not provide a specific direct prohibition against running conduit on other trade supports, such as those used for ductwork. The permissibility often hinges on interpretations of general requirements for support, securement, and protection of electrical wiring methods. Several sections of the NEC address these considerations. Firstly, NEC Section 300.11, titled Securing and Supporting, provides guidelines for the proper installation and support of wiring methods. Specifically, 300.11 addresses securing electrical boxes, conduit bodies, and fittings. These items must be securely fastened to the surface on which they are mounted. The intention is to ensure that these components are mechanically stable and will not be dislodged by vibration or other forces. Secondly, 300.11 B covers the support of cables. Cables must be supported by straps, staples, hangers, or similar fittings designed and installed so as not to damage the cable. The spacing of these supports must comply with the requirements of the specific cable type, as detailed in the relevant article of the NEC. Thirdly, and pertinently, 300.11 C, titled Wiring Methods Installed in Other Spaces Used for Environmental Air, addresses situations where wiring methods are installed in spaces used for environmental air, such as above suspended ceilings used as a plenum. In these spaces, wiring methods must be supported independently of the suspended ceiling. This means that the conduit or cable must be supported by its own hangers or supports that are attached to the building structure and not simply laid on top of the ceiling grid or supported by the ceiling support wires. While this section is specifically directed at plenum spaces, it reflects the broader concern that wiring methods should be independently supported and not rely on other building systems for support. Another relevant section is NEC Section 300.4, titled Protection Against Physical Damage. This section provides general requirements for protecting wiring methods from physical damage. 300.4 addresses protection against damage from nails and screws. Where wiring methods are installed in locations where they may be subject to damage from nails or screws used by other trades, they must be protected by a steel plate or sleeve. 300.4 B addresses protection against abrasion. Where wiring methods pass through holes in framing members, the edges of the holes must be smooth and rounded to prevent abrasion of the wiring. 300.4 C addresses cables and raceways parallel to framing members. Where cables or raceways are run parallel to framing members, they must be installed so that they are protected from physical damage. 300.4 D specifically deals with installed in raceways. If the conduit is installed in a raceway, the raceway must be securely fastened and supported. The concern here is that if the conduit were to be attached to a ductwork hanger, the ductwork hanger may not be designed to support the weight of the conduit, especially if the conduit is filled with conductors. This could lead to the ductwork hanger failing, which could then damage the conduit and create a safety hazard. The NEC also addresses the installation of electrical equipment in general in Article 110. Section 110.12, Mechanical Execution of Work, requires that electrical equipment be installed in a neat and workmanlike manner. This includes ensuring that all equipment is properly supported and secured. Section 110.3 B requires that listed or labeled equipment be installed and used in accordance with any instructions included in the listing or labeling. This means that if the conduit or the hangers used to support the conduit are listed or labeled, they must be installed in accordance with the manufacturer's instructions. While the NEC doesn't explicitly forbid running conduit on ductwork hangers, the general requirements for support, securement, and protection often lead to the conclusion that independent support is necessary. The concern is that ductwork hangers are designed for a specific purpose to support ductwork, and their load-bearing capacity and suitability for supporting electrical conduit may not be adequate or guaranteed. Considerations for this include, firstly, load capacity. Ductwork hangers are designed to support the weight of the ductwork, which may be significantly different from the weight of the conduit, especially if the conduit is large or contains many conductors. The additional weight of the conduit could overload the ductwork hanger and cause it to fail. Secondly, vibration. Ductwork systems often vibrate, and these vibrations could be transmitted to the conduit if it is attached to the ductwork hanger. This could damage the conduit or the conductors inside the conduit. Thirdly, dissimilar metals. Ductwork hangers are often made of different materials than conduit, and this could lead to corrosion if the two materials are in direct contact. Fourthly, accessibility. Conduit must be installed in a way that allows for easy access for inspection, maintenance, and future modifications. Attaching conduit to ductwork hangers may make it difficult to access the conduit. Fifthly, code compliance. As discussed above, several sections of the NEC could be interpreted to require that conduit be installed on its own dedicated hangers. Because of these concerns, it is generally best practice to install conduit on its own dedicated hangers. This ensures that the conduit is properly supported, protected, and accessible, and that it complies with the requirements of the NEC. It is also important to consult with the local authority having jurisdiction to determine whether or not it is permissible to run conduit on ductwork hangers in your jurisdiction. The AHA has the final say in interpreting the NEC and enforcing its requirement. They may have specific rules or interpretations regarding the use of ductwork hangers for supporting conduit. To summarize, while the NEC doesn't have a specific prohibition, several factors and general requirements make it advisable to use independent supports for conduit. These factors include load capacity, vibration, dissimilar metals, accessibility, and code compliance. Always consult with the local AHA to ensure compliance with all applicable codes and regulations. Consider a scenario where a contractor is installing electrical conduit in a commercial building. The contractor notices that there is already existing ductwork in the area where the conduit needs to be run, and the ductwork is supported by hangers. To save time and money, the contractor decides to attach the conduit to the ductwork hangers instead of installing separate hangers for the conduit. However, the electrical inspector arrives on the job site and notices that the conduit is attached to the ductwork hangers. The inspector informs the contractor that this is not acceptable and that the conduit must be supported by its own dedicated hangers. The inspector explains that the ductwork hangers are not designed to support the weight of the conduit and that the vibrations from the ductwork could damage the conduit over time. The inspector also points out that attaching the conduit to the ductwork hangers could make it difficult to access the conduit for future maintenance or repairs. The contractor is forced to remove the conduit from the ductwork hangers and install separate hangers for the conduit. This costs the contractor time and money, and it also delays the completion of the project. This scenario illustrates the importance of understanding the NEC requirements for supporting conduit and the potential consequences of not following those requirements. By installing conduit on its own dedicated hangers, the contractor can ensure that the conduit is properly supported, protected, and accessible, and that it complies with the requirements of the NEC.